Hi there, and welcome to the very first interview session after a virtual jug session, which is on the Rebel Labs site, the media sponsor for the virtual jug. Today, we literally just got off a session with James Gosling, absolutely amazing session, which blew all our records for numbers. And today, Oleg, the head of Rebel Labs, is going to interview James Gosling, creator of Java, and now CTO of Liquid Robotics. So first of all, hello, James.
Hi.
Good to see you again. We only talked maybe 30 seconds ago.
Yeah.
I'll pass straight over to Oleg, who's going to start the interview.
Yeah, Jane, thanks for agreeing for this interview, and without further ado, let's just go into the questions. So first of all, thank you for the amazing and very inspiring session about the Wave Glider project that showed us the real software that interacts with real world, and will maybe bring this interview more into Java. So what do you think? What has been the most surprising thing to you about how the Java ecosystem and community has evolved over those 20 years that it is available now?
It's hard to pick out any one thing, but it's a sort of combination of strength and diversity. You find people doing just the coolest, strangest, weirdest things off in corners. You find the mind-boggling array of libraries that you have in the Java world, and the projects behind them. I spent a good chunk of the last few days, spending a lot of quality time with Apache Zookeeper, and oh my Lord, is that ever a wonderful piece of software? And to have an ecosystem where stuff of that kind of quality and teams of that kind of size, and you see the kind of stuff that people do with it, right? Zookeeper is underneath some really large fraction of all the world's giant distributed systems, and systems like that are just all over the map.
Exactly. So you mentioned libraries and the availability of all kinds of libraries as one of the benefits of going with JVM as a platform in the virtual jug session as well. And also you said that resilience of the JVM is something you appreciate a lot in the Wave Glider project as well. So what else goes like a big time helps Java to be a superior and super platform, like in your opinion? Like what are the main features that why everyone should?
Well, so for the one of the Java features that people hardly think about is the way linking works, linking between modules. So if you look at the Java class file format, there are no fixed offsets to things. It's always symbolic references, and there are strong rules that decide how dynamic linking works across version changes. And one of the things that's done is it makes it really easy for libraries to change version without the code that depends on them having to change. And that's been just huge in building this API ecosystem. So if you look in like the C world, right, just the smallest change in a C struct, and everything that uses it has to recompile. So one of my big pain points in the Linux world has been that they've historically had a tremendous willingness to change APIs at the drop of a hat in ways that break applications. Now they've gotten a lot better, but it used to be that even small version bumps in Linux and you'd have to recompile. And it still tends to be that way with a lot of the libraries. So managing libraries and library evolution, and really the coevolution of components in a way that's not brittle, has been really, really important. And most people, they don't even think about it, right? They just grab the latest library and they just use it.
And that is one thing that enabled growing such a huge ecosystem of libraries and frameworks for everything in Java.
Yeah, they're just easy to use.
So if that is going for Java, so what could be one unsolved question that stands before the Java developers, the Oracle and open source OpenJDK developers that are evolving Java? What could be the major unsolved thing?
Major unsolved thing. Well, when I end up in, programming language heated debates, the biggest tension is often about how quickly can you rapidly put something together, and how sort of reliable and durable and scalable can the system be. So you take things like strong types and the exception mechanism, and the rules around the way classes are organized. For people from the scripting language world, they go, well, why do you straitjacket us like that? That's silly. And yet they end up getting screwed when they have stuff that's very, very brittle and doesn't evolve properly, and it's very, very hard to get decent performance, right? So we get huge performance boosts over any of the scripting languages when you have very large teams of people working on something. All these weird features, around classes and types and organization and that, they're what really save your ass when you have large sophisticated systems, large teams, difficult testing environments. They're what make it work. And one of the tensions has always been between trying to make things easy and quick to slap together, and without losing the sort of the features that make scale work.
Yeah, that is a great answer. So we'll go with the last kind of longer question. So if you would be able to go back in time and give the young developer in you a piece of advice, what would that be? Just a really short one, maybe. Like to the time when you were writing your PhD thesis and swimming in parentheses. Or even younger.
Boy, it would have been sell Sun stock in 2000. That's probably the shortest one. But
no, a developer-related advice. Oh.
Yeah, I mean probably the thing I regret the most was sort of backing down on operator overloading. I'm not sure that I know the right answer. One of the difficulties with operator overloading is that there are a lot of ways to do it that aren't really great. But I think I think I wimped out on that one.
Okay, thanks for that. So let's go really quickly to the blitz questions. So just without any.
So I'm running out of time. My wife is like literally trying to drag me away. So
okay. So
let's do like one more question and we call it a day.
Yeah. So is computer science a real science? Let's go with that one.
Is it a science? Well,
yeah,
depends on what you mean by a science. If a science is one where you do experiments because you don't know how they're going to turn out, and then you try them. Yeah, people do experiments in computing all the time. Some of them are experiments with different algorithms, experiments with different ways of approaching this and that. The world of algorithms is essentially pure math, and so is pure math a science? I think most people would call it a science because most of physics is pure math and yada yada. So yeah, but the kind of journeyman stuff that people do, knocking out yet another web page, yeah, that's not science. Building the fault-tolerant back end and figuring out how to do something like the simian army testing, that's science.
Thanks a lot. It's a great answer. It's been a great pleasure to have you here. Thank you for your time again. This interview will be available on the Rebel Labs website in a short while.
All right. Well, thank you. Thank you very much for inviting me.
Thanks a lot.
Okay. Bye.
Bye-bye.